Welcome to Chapter 13 problem session. Chapter 13, of course, deals with taxes and specifically more with corporate taxes. Um, I'm going to work two problems in this particular session, and these two problems deal with homework problems, actually. They're in the homework assignment. The first problem, I deleted parts of it from the homework because the author worked the problem, part C in particular, worked it wrong. I'm going to work it correctly here, and I'll work part A, which is actually the part that's the homework problem for you. So let's read the problem, and when you read problems, you want to read them carefully, and you want to basically state what you know and what you don't know, what you're looking for. And so let's go with this one. It says business and engineering seniors are comparing methods of financing their college education during their senior year. The business student has $30,000 in student loans that come due at graduation. So we'll assume that's 1 year, okay, the senior year. Interest is at an effective rate of 4%. The engineering senior owes $50,000, 50% of from his parents with no interest due. Okay, so 50% of 50,000 is 25,000 of his loan has no interest due, and 50% from the credit union. This latter amount, this other 25,000, is due at graduation with an effective rate of 7% per year. What is the DE mix for each student? Well, DE basically stands for debt. D is debt. In other words, how much loans do you have? And E is equity. And equity is what the owner of something, in this case it's a student, okay, it's the owner of the student, how much they put into it. Well, this particular problem doesn't talk about the student working or having saved money before they went to college or anything like that. So we don't know anything about equity, so we're going to have to assume there's no equity. All the money that came from either, in the case of the business student, the student loans, or in the case of the engineering student, parents and credit union loan. Okay, well, the second part, let's work one part at a time. So that's part A, and that's, I think, the part that's on your homework. The DE mix is the percent of the total investment that comes from debt or borrowed funds and equity or owner's funds. So debt for the business student, I call that D sub B for business, is 30,000 in student loans, and debt for the this should be engineering student, and I'll correct that. That's what happens when you copy and paste. Is 25,000 in student loans from the parents and 25,000 in loans from the credit union. So that D sub E is 25 plus 25. That's $50,000. There is no mention of either student supporting their education from their own savings or earnings. So E is equal 0 for both students. So the debt equity mix for both students is 100% debt, 0% equity. It's kind of a dumb question, or I don't know. So we'll go on. If their grandparents pay the loans in full at graduation, what is the amount on each check they write for each graduate? So let's take a look at the business graduate first. For the business graduate, they must pay $30,000 times 1.04. And actually, that's kind of the F given P factor for 1 year, okay? And that would be 1 plus I to the 1, which is just 1 plus I, which is 1.04, times 30,000. So they have to write a check for 31,200 to the credit union. For the engineering graduate, they must pay 25,000. Remember, that loan had no interest on it to the parents. So that would be 1 plus I to the 1, but I is 0, so that's just 1 to the 1, which is 1. That's $25,000 to the parents, and they'll have to write another check for 25,000 times 1.07 to the 1, which is 26,700 to the credit union. Of course, there's 7% interest on that loan. And then part C, the question is, when the grandparents pay the full amount at graduation, what percentage of the total amount due does the interest represent? Well, the total amount due is not what they borrowed, it's what their check is going to be. So I put for the business students, by the way, the answer key did it based on what they borrowed, not what was due, but the question asked based on what was due. So they paid in this case, they paid $1,200 worth of interest, and they wrote a check for $31,200, so that's 3.846%. For the engineering graduate, they wrote actually 2 checks, one for $25,000 and one for $26,750, which when you add those two up, they add up to $51,750, of which the $1,750 was the interest, okay? And so that turns out to be 3.38%. So that's the problem. At the end of the chapter, this is problem number 3.42, and it's one of the homework problems, but I think I was able to delete parts B and C, and I think you're only going to answer part A. That's my guess. So the next question that I'm going to deal with is at the end of the chapter, it's problem 13.53. And again, it is also one of the problems in your homework assignment, and it's out of a section 13.7 in the book that we didn't cover, and I could not delete it from the homework assignment. So I had to just leave it in there, and that's why I'm working it for you so you can have the right answer, okay? And also it basically will allow me to do use this problem session to do a lesson, okay? The author says, in conducting an EVA analysis for year 2, economic value analysis, and we haven't covered that, but that's what I'm telling you it is, for a newly introduced product line, Bethune Inc., which manufactures pre-assembled blower packages and other water treatment components, determined that the EVA to be $28,000. Now this is the EVA value, economic value analysis value, for this component is $28,000 in year 2. Okay, $28,000 in year 2. The company uses an after-tax interest rate of 14%, and the effective tax rate is 24%. The initial investment capital required for the new product was $550,000, and all equipment is 3-year MACRS depreciated. So that means it's going to be depreciated actually over 4 years, as you know. And the table in Chapter 12 was where you would get the depreciation factors, and they will be provided to you on the final exam. Bethune's CEO knew that the gross income was $700,000, and that's in year 2. Everything we're talking about is year 2, but he asked you to find out how much expenses was associated with the new product line for year 2. So we're looking for E2, and there's a bunch of equations we've got to go through. But let's start with what we're given and what we know. We're given the EVA in year 2 is $28,000, okay? So I subscripted it with a 2 to represent year 2. And we're given that the after-tax interest rate, which I called I, is 14%. And we're given that the price was for the equipment was $550,000, which is also the book value at time 0, $550,000. And we're given that the gross income in year 2 is $700,000, and we're asked to find the expenses in year 2. Well, as I said, you're going to have a bunch of equations. The material in section 13.7 was not covered in the lecture, so I'm working this problem for you, okay? The authors define net operating profit after taxes, NOPAT, as the taxable income minus the taxes as shown in equation 1317, which we did not cover in the lecture. So NOPAT equals taxable income minus taxes, and taxes are taxable income times the tax rate. So if we factor out taxable income, we get also taxable income times 1 minus the tax rate is NOPAT. The economic value added, EVA, is defined by equation 1318 as the net operating income, that's this thing, after taxes, minus the cost of invested capital. Well, that's another term we haven't used before. What's the cost of invested capital? Substituting for NOPAT the right-hand side of equation 17, that term there, and defining the cost of invested capital to be the after-tax interest rate times the book value at the end of year T minus 1. So if we're looking at year T, which in this case T is 2, remember, okay, then this would be the book value at time 1. Well, we know the book value at time 0. We know the MACRS depreciation is 3 year. And so we can go look up in the table what our depreciation will be, the factor in year 1, and then multiply it by the $550,000, which we'll do in a little bit. The cost of invested capital, therefore, in year T is I, that's that 14% up there, times BV T minus 1, which is T is 2, so this will be book value at time 1. Combining this equation with the prior one yields equation 1318. So we're looking at this, and then the one for economic value analysis. We're combining these two equations, and we get that the economic value analysis is NOPAT. NOPAT, remember, is this thing right here. So I put that here, minus this, which is the cost of invested capital. So that's equation 1318. So in order to solve now for the expenses in year 2, it's going to take a 4-step process. And these are the steps that are required. First, I need to find the book value at time 1. Okay. The next thing I need to do is, since once I have the book value at time 1, I can solve. I can also solve for NOPAT. And then I can find the taxable income from NOPAT using equation 1317. So what I'll be solving for is this in this equation, or actually, if I look at this and this. If I know, once I solve for NOPAT, then I plug in here, I can get taxable income. And then solve for the expenses from the taxable income. And recall from the sections that we did cover early in chapter 13 that taxable income is equal to gross income minus the expenses minus depreciation. Okay, so that is an equation that we'll solve, but we're going to solve it for the expenses. We're going to know the taxable income. We were given the gross income way back up here of $17,000. We solved for taxable income. We know the depreciation. That'll give us expenses. So that's the process I'm going to go through, and go through it step by step. Let's see if I can keep my steps up here and then go through them. The first step, find the book value. You know how to do that from chapter 12. The original price is the depreciation, is the book value at time 0. Okay. Minus the depreciation in year 1 gives you, well, that'll be the depreciation in year 1, which will give you the book value. Okay. Well, what's the depreciation in year 1? Depreciation in year 1 is the depreciation factor times the original price. Remember, 3-year property under MACRS is depreciated over 4 years, and the first year the factor is 0.3333. So we multiply that depreciation factor times the original price to get the fact that there's $183,315 depreciation in year 1. And then the book value then is the original price minus the depreciation. Normally, the book value in some year, BV sub t, would be BV sub t minus 1 minus D sub t. In this case, t is 1. This will be book value at time 0, which is just the price. And this is the depreciation in year 1, which is this number. Okay, so I get that the book value after 1 year, you depreciated $183,315 out of the original $15,000. So your remaining book value is $366,685. So we know book BV1. We did step 1 now. Now step 2 is to solve for NOPAT. We have this equation that involves NOPAT and invested capital. So we have EVA2 equals, and we know what that is, by the way. We were given EVA2 of 28,000. Okay, so EVA2 is 28,000, which is NOPAT minus cost of invested capital. Okay, so we have 28 equals 28,000, which is NOPAT for year 2 minus 28,000, and so we know, minus cost of invested capital, which is cost of invested capital is given by, where is it? There. It's given by I times BV t minus 1. So we just solve for BVT minus 1 to get this number, and we're going to multiply that times the cost of invested capital, which we were given originally as 14%. So we'll do that. When we do that and solve this equation for NOPAT, we only have one unknown, one equation. We would add this to both sides and get NOPAT equals $79,336. Okay, so the next step then is to find the taxable income from the NOPAT using equation 1317. Let's see, it's right. Where's 1317? It's right there. And so we're going to plug into that equation specifically T taxable income times 1 minus the tax rate equals NOPAT, okay? And when we do that, we'll solve for taxable income. We now know NOPAT. So, oh, I'm sorry, I've been blocking out myself here. Sorry about that. NOPAT then equals, again, going back to equation 1317. Maybe I should write it there. 1317 it says NOPAT equals TI, taxable income, times 1 minus the effective tax rate. Now we know what NOPAT is, and we know what the tax rate is, so all we have to do is solve that equation for TI, which is taxable income. And that's in year 2, of course, and this is the NOPAT in year 2. So anyway, we solve for taxable income. We ended up with $104,389, and then finally we need to solve for what the question wanted. Solve for E, which is really E2 from the taxable income. And remember this equation from early in the chapter. Taxable income is gross income minus expenses minus depreciation. So in year 2 now, the first thing we need then is to find what is the depreciation in year 2. Well, we take and multiply the factor from the table, which in year 2, remember in year 1 it was 0.3333. In year 2 it's 0.44545. Multiply that times the original price. The second year depreciation of that machine is $244,475. And so when we plug into the equation that says taxable income equals gross income minus expenses minus depreciation, we know everything except expenses. And so we know taxable income, we know the left side of the equation, we know the gross income is $700,000, unknown expenses, the depreciation, we just calculated $244,477, and so we end up with getting E2 isolated on one side of this equation, and when we do, we find out that E2 was $351,136. So that's this problem 1353. You will not be responsible for this kind of analysis on the final exam because we didn't cover section. This came from section 13.7 in the book, and we kind of ran out of time because of Hurricane Laura and didn't finish the remainder of chapter 13. But since it was on the homework assignment, and since I could not remove it from the homework assignment, I worked it here today for you. And that will conclude today's problem session, and we'll have a review for the final pretty soon. Thank you.